Hi, I am Syed on Mass Online. Today's topic will be radius of curvature. So let us first try to understand what curvature is. Then I'll give you the definition of radius of curvature. I'll try to explain the definition with the help of a figure. Let us consider the coordinate axis, x and y axis. This is your x axis and this is your y axis. Let us consider a curve, draw tangents. Let me consider a point A on the curve. And let me draw tangents to the curve, say at the point P. I'm drawing a tangent which is making an angle of psi with the x-axis. Similarly, I am drawing a tangent at the point Q, and the angle between these two tangents is delta psi, which means that these points P and Q are very close to each other. Therefore, the angle between these two tangents is very small. I am taking that angle to be equals to delta psi. So, if this is delta psi, then this will also be equals to delta psi because of vertically opposite angles, it becomes delta psi. Now, if this angle is psi and delta psi, then this exterior angle will be the sum of the opposite interior angles, which will be psi plus delta psi. So that is the exterior angle we have. So we have considered a curve in the coordinate plane, and I am considering the 2 points on the curve P and Q which are very close to each other. The arc length AP, I am taking that value to be equals to S. Let me take the arc length PQ to be equals to delta S. Means that the point P and Q are very close to each other. Then the arc length AQ will be equals to the sum of AP plus PQ. It will be S plus delta S. So what does this delta psi angle represent? Now here this delta psi represents the bending of the given curve. So in this case delta psi will represent the bending of the curve. It represents the bending of the curve. So which means that because since it is the angle between the two tangents, suppose if the delta psi represents the bending of the curve, and this bending of the curve depends upon the arc length PQ. That means the distance between P and Q. If the distance between P and Q is large, then the value of delta psi will be large. If the distance between P and Q is small, then this angle between the two tangents delta psi will be small. Since the point P and Q are close to each other, therefore the value of delta psi is also small. So therefore it represents the bending of the given curve. As the distance between P and Q increases, the bending of the curve will also change. Whereas this delta psi by delta S represents the curvature. Here delta psi by delta S represents the mean curvature of the arc PQ. So this delta psi by delta S will represent the mean curvature of the arc PQ. As the distance between P and Q changes, this delta psi by delta S will also change. Therefore, since it is delta psi represents the bending of the curve, then the amount of bending of this curve at the point P will be called as the curvature of the given curve at P. And mathematically, we can represent the curvature as delta psi by delta S as limit delta S tends to 0, which means that this point Q is approaching the point P. So as the point Q approaches the point P, so as this point Q approaches the point P, as it comes closer and closer to the point P, then the amount of bending of the curve will reduce, which means that this delta S distance between P and Q will reduce. So mathematically we can represent the curvature as delta psi by delta S as limit delta S tends to 0. So delta S tends to 0 means the distance between P and Q reduces when the value of Q approaches P. So in that case we can write down this limit value to be equals to d psi by ds. Now this d psi by ds is called as the curvature of the given curve, and it is represented by capital K. So the curvature of the given curve is represented by capital K. So therefore you can write curvature capital K is equals to d psi by ds. So this is called as the curvature of the given curve. So the reciprocal of the curvature is called the radius of curvature, and this radius of curvature is represented as rho. So therefore you can write rho to be equals to the reciprocal of curvature. Since curvature is represented as k, its reciprocal will be 1 by k. But we know the value of k is d psi by ds. If I take the reciprocal, I will be getting ds by d psi. So this ds by d psi is called as the radius of curvature. Hence we got the basic mathematical definition for the curvature, which is k is equals to d psi by ds, and the mathematical definition for the radius of curvature, which is the reciprocal of the curvature and represented by ds by d psi. Now let us try to see the expression for radius of curvature in the Cartesian form. Suppose if I consider the Cartesian curve, say y is equals to f of x. For this given curve, the radius of curvature can be written as rho is equals to 1 plus y1 square to the power of 3 by 2 whole divided by y2. So this rho value represents the radius of curvature for the curve y is equals to f of x, where this values of y1 will represent the first order derivative, which is dy by dx, and y2 value represents the second order derivative d square y by dx square. So we have seen for the curve y is equals to f of x, the radius of curvature. Similarly, suppose if the curve is in the form of x is equals to f of y, in that case we can write down the radius of curvature to be equals to rho is equals to, it is 1 plus x1 square to the power of 3 by 2 whole divided by x2. Here y is the independent variable, x is the dependent variable. So in this case the value of x1 will be equals to, it is dx by dy. So as the value of x is a dependent variable and y is an independent variable, therefore x1 can be written as dx by dy. Similarly, you can write x2 to be equals to d square x by dy square. So we have obtained the expression for radius of curvature for the curve y is equals to f of x, as well as for the curve x is equals to f of y. So let us take few examples based on these formulas. So let's start the first question. Show that the radius of curvature for the catenary of uniform strength y is equals to a log secant x by a is a secant x by a. We have to show that radius of curvature is equals to a secant x by a. So given the curve y is equals to a log secant x by a, and this curve is called as the catenary. So let us start the solution. We know the radius of curvature is given as rho is equals to 1 plus y1 square to the power of 3 by 2 divided by y2. So let me take this as equation number 1. Try to observe here, I need to find out the value of y1 and y2. So We know the value of y1 is nothing but dy by dx, and the value of y2 is nothing but d square y by dx square, which means suppose if I try to differentiate this dy by dx, I'll be getting the value as d square y by dx square, and this d square y by dx square is nothing but y2. So which means that if you try to differentiate y1, you will be getting the value of y2. So I need to find out that y1 and y2. So given the curve y is equals to a log of secant of x by a. So I need to differentiate this with respect to x. Differentiate with respect to x. So derivative of y, which is dy by dx, can be written as y1 is equals to a as it is. Differentiation of log will be 1 by. It will be 1 by secant of x by a. So derivative of log is complete. Then move inside, you have secant. So differentiation of secant will be secant into tan. So secant x by a into, it is tan of x by a. Further, the differentiation of x by a will be 1 by a. So you can see that this a in the numerator and a in the denominator will cancel out. Secant x by a in the numerator, secant x by a in the denominator will cancel out. We are left out with y1 is equals to, it is tan of x by a. So let us take this as equation number 2. So y2 can be obtained differentiating this y1. So differentiate with respect to x. Differentiate with respect to x. So derivative of y1 will be y2 is equals to, derivative of tan will be secant square of x by a into derivative of x by a will be 1 by a. So we got the value of y2 to be equals to 1 by a secant square of x by a. Let us take this as equation number 3. So since you got the value of y1 and y2, you can just substitute in the radius of curvature. So substitute equation number 2 and equation number 3 in equation number 1. So we have the radius of curvature rho to be equals to 1 plus y1 square. So the value of y1 over here will be tan of x by a, and it is squared, whole power of 3 by 2. So 1 plus y1 square to the power of 3 by 2 whole divided by y2. So the value of y2 will be 1 by a into secant square of x by a. This will be equals to, it is 1 plus, so tan x by a whole square will be tan square. So tan square of x by a to the power of 3 by 2. It is whole divided by 1 by a comes in the numerator and becomes a. Denominator secant square of x by a will be as it is. So it is a times of 1 plus tan square is nothing but secant square. Secant square of x by a, its whole power of 3 by 2. It is whole divided by the denominator as it is secant square of x by a. You can see this square and this divided by 2 will cancel out. We are left out with a into secant cube will be there over here. So this power 3 will come inside, it becomes secant cube of x by a. It is whole divided by secant square of x by a. You can see the secant square will cancel out with secant square in the numerator. One secant will be left out. So therefore we get the radius of curvature rho to be equals to a secant of x by a. So in the question you can see that, so it was given that the radius of curvature should be a secant x by a. So hence we have got that solution as a secant x by a. So that's the required solution. Let us move on to the next question. The next question is find the radius of curvature for the folium of Descartes x cube plus y cube is equals to 3axy at the point 3a by 2 comma 3a by 2. So this particular curve x cube plus y cube is equals to 3axy is called as the folium of Descartes. So we know the radius of curvature formula, rho to be equals to 1 plus y1 square to the power of 3 by 2 whole divided by y2. So let us take this as equation number 1. So if you try to observe, the given curve is given in the form of x cube plus y cube is equals to 3axy. From here, I need to find out the value of y1. So let us take the given curve x cube plus y cube is equals to, it is 3axy. So we'll try to differentiate this with respect to x. Differentiate with respect to x. So x cube differentiation will be 3x square plus y cube differentiation will be 3y square into differentiation of y will be y1. On the right hand side we have 3a into, because x and y both are variable, I have to use the product rule here. X into differentiation of y will be y1 uv dash plus vu dash. So keeping y as it is, differentiate x, derivative of x will be 1. Or further, if I try to multiply over here, I'll keep 3 as it is, multiply a inside, it becomes axy1 plus ay. On the left hand side, if I take 3 common outside, so I'll be left out with x square plus y square into y1. This value of 3 will cancel out. We'll be left out with x square plus y square y1 is equals to, it is axy1 plus ay. So from here I need to find out the value of y1. So let us try to group y1 values. Keeping this y square y1 as it is, send this axy1 on the left hand side, it becomes minus axy1 is equals to, on the right hand side you have y as it is, send this x square on the right hand side, it becomes minus of x square. If I can take y1 common outside from here, I'll be left out with y square minus of ax. That will be equals to ay minus of x square, or y1 will be equals to ay minus of x square. You can cross multiply this value that comes in the denominator, y square minus of ax. We got the value of y1. So let us take this as equation number 2. But we need to find out the radius of curvature at the point 3a by 2 comma 3a by 2. So I'll try to find out at the point 3a by 2 comma 3a by 2. That means, so at the point x comma y, x value is 3a by 2, y value is also 3a by 2. So let's try to plug in over here. So I'm trying to find out the value of y1 at the point 3a by 2 comma 3a by 2 should be equals to, is a times of the value of y is 3a by 2 minus x value is also 3a by 2 and it is squared, x square is whole divided by y square in the denominator will be 3a by 2, 3a by 2 whole square, y square minus a into x, x value is 3a by 2. So that will be equals to, if we try to simplify this 3a square by 2, it becomes, second term we need to square it, it is 9a square by 4, it is whole divided by the denominator value, you need to square this one, it is 9a square by 4, it is minus of, it is 3a square by 2. If you try to observe the numerator and denominator, it's almost the same, but there is a difference of negative sign. Suppose if I take a negative sign outside from the numerator, so the first value will be 9a square by 4. The second value, because it is positive here, now it becomes negative, minus 3a square by 2. Just taking the negative sign outside, positive value will become negative, negative value will become positive. Whole divided by the denominator as it is, 9a square by 4 minus of 3a square by 2. So we see that this numerator and denominator will cancel out. So therefore you have got the value of y1 at the point 3a by 2 and 3a by 2 to be minus of 1. So that's the first value we obtained. Let us take this as equation number 3. Now I need to find out the value of y2. So the value of y1 in terms of x and y is this equation number 2. So I have to differentiate this equation 2 to obtain the value of y2. So let's try to differentiate equation number 2 with respect to x. So we'll be getting y2 to be equals to. Try to observe on the right hand side the numerator value is ay minus x square divided by y square minus ax. Since we have the variables x and y both in the numerator and denominator, we are going to use the quotient rule, u by v rule. We try to use the quotient rule. So this is the quotient rule you have, is d by dx of u by v will be equals to vu dash minus uv dash divided by v square. So that's the formula. So in this case, the value of u, the numerator value that we have is ay minus of x square, and the value of v that we have is the denominator y square minus of ax. So let's try to use the quotient rule and differentiate. So it is v value is y square minus of ax into u dash, differentiation of the numerator, that is a into derivative of y will be y1 minus derivative of x square will be 2x minus of u value is ay minus of x square into v dash, derivative of v dash will be 2y, derivative of y square will be 2y into derivative of y will be y1 minus ax, differentiation will be a. It is whole divided by v square. So v square is y square minus of ax whole square. So we got the value of y2. So let us try to find out the value of y2 at the point 3a by 2 comma 3a by 2. So let's try to simplify it over here. y2 to be equals to y value over here is 3a by 2. So it is 3a by 2 whole square minus of a into x value is 3a by 2. Then you have a into y1. So since I am finding y1 at the point 3a by 2 comma 3a by 2, which is given by equation number 3, its value is minus of 1 minus 2 into x value is 3a by 2, then minus of a into y value is 3a by 2 minus of x value is 3a by 2 whole square, 3a by 2 whole square into, so just write it over here, it is 2 into y value is 3a by 2 into y1 value at the point 3a by 2 comma 3a by 2, we have obtained that as minus of 1 minus of a value as it is. So this is the numerator value whole divided by the denominator. So in the denominator you have y square. So y value is 3a by 2 whole square minus of a into x value is 3a by 2, and it is whole square one. So let us try to simplify this one. y2 to be equals to, so the first term that you are having is 9a square, 9a square by 4 minus of 3a square by 2. So in the second term, we can see this 2 and 2 will cancel out. Here also you can see this 2 and 2 will cancel out. So if we try to simplify, this becomes minus of a, it is minus of 3a. Minus of, you have this expression to be equals to 3a square by 2 minus of, it is 9a square by 4 into. The next term that you have is minus of 3a minus of a. The denominator value will be 9a square by 4 minus of 3a square by 2, and it is whole squared. Further, if you try to simplify, y2 will be equals to, so if you try to simplify and take the LCM over here, so in this case LCM will be 4, because the LCM is 4, the first term will be as it is 9a square minus, here you need to multiply by 2, so it becomes 6a square, and this value is minus of 4a minus, so here also the LCM will be 4, so you need to multiply by 2, so 6a square minus of 9a square, this value is minus of 4a, this whole divided by denominator, also you can take the LCM as 4, so we will be getting the value to be equals to 9a square minus, multiply by 2, it becomes 6a square, and it is whole square. Further, y2 value will be equals to, so 9 minus 6 will be 3, so it is 3a square by 4 into this minus of 4a as it is, minus of, this value will be, minus of 3a square by 4, and this is minus of 4a. It is whole divided by 3a square by 4 whole square. This will be equals to, you can observe this 4 and 4 will cancel out. Here also this 4 and 4 will cancel out. So if you just try to multiply this expression over here, it becomes minus of 3a cube, and this will be minus of minus plus, plus into minus will be minus. So here also you'll be getting 3a cube whole divided by denominator, you need to square it. So therefore you'll be getting 9a power of 4 divided by 16. Further, if you try to simplify this one, this will be equals to minus of 6a cube. So denominator, if I take in the numerator, it becomes reciprocal, 16 by 9a power of 4. Cancel out, it is 3 times, 3 2 times, and a cube will cancel out with a power of 4, 1a will be left out. So hence we get the value to be equals to minus of 32 divided by 3a. So we got the value of y2. The value of y2 in terms of x and y is this equation. We'll take this as equation number 4. Now this equation that I have got, let me take that as equation number 5. So this is y2. We need to just substitute this y1 and y2 back in the given equation. So if you try to observe, the radius of curvature is nothing but the equation number 1, and the value of y1 that we have got at the point 3a by 2, 3a by 2 is given by equation 3, and y2 is given by equation number 5. So we'll try to substitute equation number 3 and equation number 5 back in equation number 1. Therefore the radius of curvature rho will be equals to, it is 1 plus y1. y1 value is minus 1, so y1 square will be minus 1 whole square to the power of 3 by 2 whole divided by y2. y2 value we have got is minus 32 divided by 3a. Try to simplify this one. This is 1 minus 1 square will be 1 to the power of 3 by 2 So if I take the reciprocal, it becomes minus 3a by 32. If you further simplify, this is 2 power of 3 by 2. Can I write this as 2 cube whole power of 1 by 2 into it is minus 3a by 32. Or further, if you try to simplify it, 2 cube will be 8 and power half represents square root of 8 into it is minus 3a divided by 32. Or further, you can write root 8 to be 2 root of 2 into minus 3a divided by 32. You cancel out the term to 1 times, 2 16 times. So this will be equals to minus 3 root 2a divided by 16. Now this can further be written in the form of minus 3 root 2a divided by, this can be written in the form of 8 times of 2. 16 can be written as 8 times of 2. Or further I can simplify 3 root 2a divided by 8 into, so 2 can be written as root 2 into root 2. You can cancel out root 2 and root 2. So we are left out with rho to be equals to, it is minus 3a by 8 root of 2. Now since this radius of curvature represents the length cannot be measured in terms of negative values. Therefore, we will be taking the modulus over here. So let us take the modulus on both the sides. So therefore, we get the positive value modulus of rho to be equals to, it is 3a by 8 root 2, which represents the radius of curvature. Therefore, the radius of curvature is 3a by 8 root 2. That is the required solution. So that's all I have for today. Thank you.